Hey guys, welcome back to A&D Tutorials. I'm Dan Orbe, grade 11 student of Rizal National Science High School. We are going to relate the derivative of a function to the slope of a tangent line. What is a tangent line? What are derivatives? A tangent line is any straight line that touches the function at only one point. Well, slope is the rate of change that varies in a line or curve. When we talk about derivatives in calculus, we talk about direction, or as I've said earlier, the rate of change of a function in any given point. Derivative measures the steepness of a graph of a function at some particular point on the graph. Now, why am I talking about these things? Why did I jump from tangent lines to derivatives? Well, we have Alexa to explain all of those concepts to us. Alexa, take over the vlog.
Hi guys, I'm Alexa Egbalic from grade 11 Newton, a student from Rizal National Science High School. In this video, you will learn about relating the derivative of function to the slope of a tangent line. But before that, I'm gonna tell first the purpose of this video as well as objectives of the lesson. Hi guys, Dan already discussed what the derivative is, so I'm gonna start to discuss how to find the derivative of a function using its own definition or the definition of a derivative. So, let's start. The purpose of this video is to explain and imply knowledge about certain complex mathematical concepts in a coherent way or in a more understandable way to make learning easy. Objectives of this lesson are the following. First, define the derivative. Second, what is the slope of a tangent line? Third, what is the relationship between the slope of a tangent line and derivative of a function? And last, find the derivative of a function using the definition of the derivative. Lastly, we can get the derivative of a function by using its own definition or by the limit process, which is f prime of x is equal to the limit of f of x plus delta x minus f of x all over delta x as delta x approaches 0.
For our first example, we have f of x is equal to 4x. We replace x with x plus delta x minus the original function all over delta x. Then we distribute 4 to the quantity. We cancel out 4x. And simplified the function, thus giving us the derivative 4. For our second example, we have f of x is equal to 2x squared plus 6. Once again, we replace x with x plus delta x. Then, we subtract the original function all over delta x. Next, we expand x plus delta x squared. All over delta x. Then we distribute the values. Cancel out 2x squared and 6. Simplify. We factor out 2 delta x and cancel delta x. We substitute 0 to delta x. We once again distribute, giving us the derivative 4x. For our last example, we have f of x is equal to 1 over x plus 1. Then we replace x with x plus delta x. Then subtract the original function all over delta x. We find the LCD first. We look for the reciprocal of delta x, then multiply it to the function. Then we cancel out terms. We cancel out delta x and it left us with -1. Next, we substitute delta x with 0, giving us -1 over x plus 1, or if we simplify, -1 over x plus 1 squared.
There is a close relationship between derivatives and tangent lines. However, derivative is a function while tangent line is a line. By plugging in different input values, x is equal to a, the output values of f prime of x will give you the slopes of the tangent lines at each point x is equal to a. Thus, the derivative measures the slope of the tangent line.
Finally learned the relationship of the derivative of a function to the slope of a tangent line. And now, it's final time for our... Pause the video while answering the questions and just play afterwards so you can see the answers. We have a total of 5 items in the quiz. Number 1, f of x is equal to 5x squared minus 2. Number 2, f of x is equal to 6x squared plus 4x plus 7. Number 3, f of x is equal to 3 over x plus 2. Number 4, f of x is equal to 1 over x squared plus 5. And last, number 5, f of x is equal to root x plus 2. And now it's finally time to reveal the answers to the quiz, and here they are. We hope that you learned something new in the video. We hope that it has made calculus a little bit easier for you. Please share it with your classmates, friends, and teachers to also help them learn about calculus. Thank you for watching this video. Once again, I'm Dan Orbe. If you like this video, please hit the thumbs up button below and hit the subscribe button as well. If you want to get informed with the latest updates, videos, and tutorials of our channel, also hit the bell button beside the subscribe button. This is A&D Tutorials. Thank you and see you on the next video.